Welcome to tonight's journey of discovery and quiet reflection. Close your eyes and breathe in the cool night air. Tonight we travel deep beneath the ocean surface together. We will explore the dark abyssal plains in perfect peace. Here lie some of Earth's most mysterious geological formations. We call them hydrothermal vents or deep-sea smokers. This series will share 100 fascinating scientific facts. Let your mind drift into the calming oceanic depths. The water pressure increases as we sink slowly downward. Surface light fades into complete and absolute quiet darkness. Only the soft hum of our submersible surrounds us now. We are entering a hidden world of geothermal wonder. Black and white smokers rise from the seafloor ahead. These towering chimneys expel mineral-rich fluids continuously tonight. They sustain vibrant ecosystems in complete absence of sunlight. We will uncover the secrets of these thermal springs. Each detail will guide you closer to restful sleep. Let the gentle rhythm of the ocean calm your mind. Release the tension of your long and tiring waking day. Let the dark water absorb all your worries and stress. Our descent into the midnight zone begins right now. The deep ocean holds ancient secrets waiting for discovery. We will learn how fact number 1 describes the very first vent discovery. Scientists found the first submarine hot springs in 1977. Researchers navigated the submersible Alvin near the Galapagos Rift. They descended to a depth of 2,500 meters. Geologists expected to find a barren and lifeless seascape. Instead, they discovered a thriving ecosystem of unknown organisms. Water temperatures near the vents reached 380 degrees Celsius. The surrounding seawater remained near freezing at 2 degrees. This extreme temperature gradient creates a unique thermal environment. Dissolved minerals precipitate rapidly upon hitting the cold water. This chemical reaction builds towering chimneys over many decades. The 1977 expedition forever changed marine biology and geology. It proved life could exist without solar energy input. Researchers realized Earth harbored entirely alien biological communities below. This revelation opened new fields of deep-sea research. We continue to study these historic Galapagos vents. Fact number 2 explains the nature of black smokers. These vents emit fluids heavily laden with iron sulfides. The expelled water appears as thick billowing black smoke. Black smokers represent the hottest type of hydrothermal vents. Their fluid temperatures typically range from 350 to 400 Celsius. The intense heat prevents the minerals from solidifying underground. When this superheated fluid meets cold sea water, minerals crystallize. Tiny dark particles form instantly in the ocean water. These iron and copper sulfides create the dark black plume. Over time, these particles settle and build massive chimneys. Some black smoker chimneys reach heights of 60 meters. The structures grow rapidly by several centimeters each day. This growth rate far exceeds typical geological formation speeds. The towering mineral pillars often become unstable and collapse. New chimneys quickly begin forming on the broken. Fact number 3 focuses on the cooler white smokers. White smokers emit fluids at much lower temperature ranges. Their waters typically measure between 260 and 300 degrees Celsius. These vents release fluids rich in barium and calcium. Silicon also makes up a large portion of their emissions. These specific minerals create a milky white plume effect. White smokers lack the dark iron sulfides of black smokers. The mineral structures they build appear pale and ghostly. These chimneys grow at a much slower rate overall. They often form on the periphery of main vent fields. The fluids travel further through the ocean crust beneath. This extended journey cools the water before it escapes. Certain minerals precipitate underground during this longer transit time. Only the lighter colored compounds reach the ocean floor. White smokers host slightly different biological communities around fact number 4 explores the process known as chemosynthesis. Sunlight cannot penetrate the ocean beyond 1,000 meters. Photosynthesis is completely impossible in these dark abyssal environments. Vent ecosystems rely entirely on chemical energy for survival. Specialized bacteria convert toxic hydrogen sulfide into usable food. They oxidize the dissolved minerals flowing from the chimneys. This chemical reaction produces simple sugars and essential carbohydrates. These microbes form the foundational base of the food web. Billions of bacteria live suspended in the warm vent fluids. Others form thick microbial mats on the rocky surfaces. Larger animals graze directly on these dense bacterial mats. Some creatures host the bacteria inside their own bodies. This symbiotic relationship allows complex life to flourish here. Chemosynthesis mirrors how life might survive on other planets. It proves biology can adapt to extreme chemical. Fact number 5 introduces the Lost City hydrothermal field. Scientists discovered this unique environment in the year 2000. It sits on the Atlantis Massif in the Atlantic Ocean. The Lost City differs greatly from typical black smokers. Its towering limestone chimneys reach 60 meters in height. These structures emit highly alkaline fluids instead of acidic ones. The fluid pH ranges from 9 to 11 continuously. Temperatures here remain relatively low at 90 degrees Celsius. The heat comes from a chemical reaction called serpentinization. Seawater reacts with mantled rocks exposed by tectonic faults. This reaction naturally produces large amounts of hydrogen gas. Methane is also generated without any biological input here. These organic molecules provide energy for unique microbial life. The Lost City remains active for tens of thousands of years. It represents a completely different type of vent. Fact number 6 details the fascinating giant tube worms. These creatures dominate the Pacific Ocean hydrothermal vent fields. Their scientific name is Rifsha pachyptila in marine biology. These worms can grow up to 3 meters long. They lack a mouth, a stomach, and a digestive tract. Instead, they rely entirely on symbiotic bacteria for nourishment. The worms house these microbes in a specialized organ. This internal organ is called the trophisome by scientists. The worm absorbs hydrogen sulfide through its red plumes. Hemoglobin in their blood transports the chemicals to bacteria. The bacteria then produce organic carbon for the host. Tube worms grow incredibly fast in this rich environment. They can reach full size in less than 2 years. Their white chitinous tubes protect them from predators nearby. They can retract their delicate red plumes instantly when fact number 7 examines the predators of the vent ecosystem. Hydrothermal vent crabs are the apex scavengers around smokers. These pale crustaceans belong to the Bythagriidae biological family. They scuttle blindly across the jagged mineral chimney walls. Adult crabs lack functional eyes in the pitch darkness. They rely on chemical sensors to locate their prey. Vent crabs feed heavily on the giant tube worms. They use sharp claws to nip off exposed red plumes. These crabs also consume bacterial mats from the rocks. They can tolerate extreme temperature shifts in the water. The water temperature can change 50 degrees in centimeters. Crabs regulate their body heat by moving between zones. Scientists have observed them fighting over prime feeding locations. They play a crucial role in balancing the ecosystem. Their presence indicates a mature and stable vent. Fact number 8 highlights the incredible Pompeii worm species. Scientists consider them the most heat-tolerant animals known. They attach their tubes directly to active black smokers. The tail end rests in water reaching 80 degrees Celsius. Their head extends into cooler water measuring 20 degrees. This creates a massive temperature gradient across their bodies. A thick layer of fleece-like bacteria covers their backs. Researchers believe this bacterial coat provides crucial thermal insulation. The microbes might also detoxify heavy metals from the water. Pompeii worms secrete mucus to feed their bacterial blanket. They measure about 13 centimeters in total body length. Their pale gray bodies feature bright red tentacle structures. They constantly move inside their tubes to regulate temperature. These worms survive conditions that would instantly boil others. Studying them helps us understand biological limits. Of fact number 9 explains the lifespan of hydrothermal vents. These geological features are surprisingly temporary in the ocean. A typical black smoker may remain active for decades. Eventually, the underground plumbing system becomes clogged with minerals. Tectonic shifts can also reroute the subterranean water flow. When fluid stops flowing, the vent ecosystem dies quickly. The towering chimneys crumble back into the ocean floor. Organisms must migrate to find newly formed active vents. Most vent fields exist along mid-ocean tectonic ridges. These ridges mark where the Earth's crust pulls apart. Magma rises close to the seafloor in these zones. The global mid-ocean ridge system spans 60,000 kilometers. New vents constantly appear along this vast underwater mountain range. This continuous renewal sustains deep-sea life across oceans. Marine larvae drift on deep currents to populate new. Fact number 10 addresses the future of hydrothermal vents. These mineral-rich chimneys attract commercial deep-sea mining. Black smokers contain massive deposits of copper and gold. Zinc and silver also accumulate heavily in the surrounding rocks. Mining companies want to extract these valuable seafloor resources. The extraction process could destroy these fragile biological communities. Heavy machinery would crush the delicate mineral chimney structures. Mining plumes could smother surrounding organisms with toxic sediment. Many vent species exist nowhere else on our planet. Destroying a single vent field could cause localized extinctions. Scientists are actively studying these areas to protect them. International regulations currently debate the ethics of seafloor mining. Conservationists argue for preserving these unique geothermal ocean habitats. We still have so much to learn from these depths. Protecting them ensures future generations can study their. Fact number 11 highlights the extreme temperature differences underwater. Black and white smokers operate at vastly different temperatures. Black smoker fluids can reach 400 degrees Celsius. This extreme heat originates deep within the oceanic crust. Magma chambers sit just beneath the porous basalt layers. White smokers expel much cooler hydrothermal fluids into the ocean. Their temperatures range from 200 to 300 degrees. The fluid cools before it ever reaches the ocean floor. It mixes with cold seawater deep inside the rocky crust. This subsurface mixing reduces the overall thermal output significantly. Heat determines which specific minerals dissolve into the deep water. Different dissolved minerals create distinct visual signatures upon exiting. The thermal gradient shapes the entire surrounding local ecosystem. Bacteria adapt to these specific temperature zones quite rapidly. The ocean floor remains near freezing at 2 degrees Celsius. This creates a sharp thermal boundary around the fact number 12 explores the mineral composition of white smokers. White smokers release plumes rich in highly reflective chemical compounds. Barium, calcium, and silicon dominate these cloudy hydrothermal emissions. These elements form pale minerals upon hitting cold ocean water. Silica precipitates slowly to build delicate, pale chimney structures. Calcium sulfate creates a bright white suspended particulate ocean cloud. This creates the beautiful illusion of white smoke underwater. Subsurface cooling causes iron and copper to precipitate quite early. They remain trapped deep inside the fractured oceanic crust. Only the lighter elements travel upward to the dark seafloor. The resulting white chimneys grow much slower than black ones. Researchers first identified these specific mineral signatures in 1979. The pale plumes drift gracefully across the dark ocean currents. They scatter light from submersible vehicles quite effectively and beautifully. This light scattering creates a soft, glowing halo around the vents. The mineral composition supports unique strains of chemosynthetic. Fact number 13 details the composition of black smoker fluids. Black smokers eject fluids saturated with dark, heavy metallic elements. Iron sulfides create the signature pitch-black billowing underwater clouds. Copper and zinc sulfides join the iron in this mixture. These metals remain dissolved only at extreme pressures and temperatures. The sudden encounter with freezing seawater forces immediate chemical precipitation. Tiny dark particles form instantly in the turbulent mixing zone. Billions of these suspended particles create the thick black smoke. The heavy metals settle quickly around the vent bay structure. They build massive, sturdy chimney structures over several long years. The Godzilla vent in the Pacific reached 40 meters tall. It eventually collapsed in 1996 due to its massive weight. The rich metal deposits attract significant commercial mining interest today. These sulfide mounds contain highly concentrated valuable rare earth elements. Scientists study these deposits to understand ancient terrestrial ore formations. Many terrestrial copper mines originated as ancient seafloor black. Fact number 14 explains the continuous chimney formation process. Hydrothermal chimneys grow through a constant process of mineral precipitation. The superheated fluid exits the seafloor at incredibly high velocities. It immediately collides with 2 degrees Celsius deep ocean water. This sudden thermal shock forces dissolved minerals out of solution. Anhydrite is always the very first mineral to precipitate out. It forms a porous foundational ring around the vent opening. This initial ring provides a scaffold for further mineral deposition. Iron and copper build up the interior chimney structure rapidly. The chimney grows upward as the hot fluid continues flowing. Vertical growth rates can exceed 30 centimeters in a single day. The structure eventually seals itself against the cold outside water. This insulation allows the internal fluid to remain extremely hot. Sometimes the chimney top seals completely with solid mineral deposits. The intense pressure then forces the fluid out through the sides. This creates complex, branching structures resembling strange underwater mineral. Fact number 15 reveals the unpredictable lifespans of hydrothermal vents. Hydrothermal vent fields possess surprisingly variable and dynamic geological lifespans. Some black smokers remain active for only a few short decades. Fast-spreading tectonic ridges create highly unstable geological seafloor environments. Magma movements frequently disrupt the delicate subsurface geological plumbing systems. Once the flow stops, the surrounding ecosystem quickly collapses completely. The ocean currents eventually scatter these collapsed mineral structures away. However, slow-spreading ridges host much older and stabler hydrothermal systems. The Mid-Atlantic Ridge features vents lasting tens of thousands of years. The Tag hydrothermal field has been active for 50,000 years. Its massive mineral mound measures 200 meters across today. The stable tectonic environment allows massive sulfide deposits to accumulate. Researchers use radiometric dating to determine the age of chimneys. They measure the decay of uranium isotopes within the minerals. This reveals a complex history of active venting and dormant periods. The total longevity of a vent dictates its biological. Fact number 16 introduces the famous Lost City hydrothermal field. The Lost City field represents a completely unique vent system. Scientists discovered this remarkable site in the year 2000. It sits on the Atlantis Massif in the deep Atlantic Ocean. These white smokers do not rely on subsurface magma heat. The heat generates through a chemical reaction called geological serpentinization. Seawater reacts directly with exposed mantle rocks called solid peridotite. This exothermic reaction produces substantial heat and pure hydrogen gas. They possess a pH level between 9 and 11 points. The fluid temperatures remain relatively low at 90 degrees Celsius. The chimneys consist entirely of pale calcium carbonate mineral deposits. They form massive, pale limestone towers up to 60 meters tall. They resemble intricate stalagmites from terrestrial underground limestone caves. Methanogens consume the hydrogen gas to produce simple methane compounds. The Lost City might resemble early Earth oceanic chemical environments. Scientists believe life could have originated in similar alkaline vents. Fact number 17 examines the extreme pH differences between fluids. The acidity of hydrothermal fluids varies widely between vent types. Black smokers typically emit highly acidic superheated subterranean water. Their pH levels often range from 2 to 3 points. The acidic nature allows the water to dissolve heavy metals. It strips iron and copper from the surrounding basaltic rocks. The acidity comes from hydrogen sulfide and dissolved carbon dioxide. Deep-sea organisms must evolve specialized mechanisms to survive this acidity. White smokers generally present a much more neutral pH profile. Subsurface mixing dilutes the acidic components before they ever exit. Alkaline vents sit at the extreme opposite end of the spectrum. Their basic fluids create a stark chemical contrast with seawater. The deep ocean water maintains a slightly alkaline pH of 8. The mixing of different pH fluids creates chemical energy gradients. Microbes harness this precise proton gradient to synthesize vital ATP. This chemical mechanism mirrors cellular respiration in human biological bodies. The fact number 18 describes the supercritical phase of deep water. Water behaves strangely at the extreme depths of black smokers. The immense pressure prevents the superheated water from ever boiling. At 3,000 meters, pressure reaches 300 total atmospheres. The fluid reaches temperatures exceeding 374 degrees Celsius. This specific combination pushes water past its critical physical point. It becomes a supercritical fluid with entirely unique physical properties. Supercritical water acts as both a gas and a liquid. This unique state makes it an incredibly powerful chemical solvent. It easily dissolves silicates and heavy metals from solid rock. The supercritical fluid carries massive quantities of dissolved minerals upward. It flows through the crust with almost zero physical friction. Scientists first observed supercritical venting in the year 2008. They found it at the Turtle Pits vent in the Atlantic. The fluid exited the seafloor at 407 degrees Celsius. Understanding this phase helps explain global oceanic chemical mineral. Fact number 19 highlights the crucial role of oceanic magnesium. Magnesium plays a vital role in the hydrothermal circulation cycle. Seawater naturally contains high levels of dissolved magnesium mineral ions. Cold ocean water slowly sinks into deep cracks in the crust. As it descends, the geothermal heat gradually warms the water. At 150 degrees Celsius, a critical reaction occurs. The magnesium drops out of the seawater completely and entirely. It binds with the surrounding basalt rock to form clay minerals. This specific chemical reaction releases hydrogen ions into the water. This newly acidic water can now dissolve other heavy metals. Without the removal of magnesium, black smokers could not exist. The exiting hydrothermal fluid contains absolutely zero natural magnesium ions. Scientists use this zero magnesium marker to test vent fluid purity. The crust absorbs millions of tons of oceanic magnesium annually. This process perfectly balances the magnesium entering from terrestrial rivers. The ocean's chemical composition relies entirely on this deep subterranean. Fact number 20 explores the acoustic environment around hydrothermal smokers. Hydrothermal vents produce distinct and complex acoustic signatures completely underwater. The violent expulsion of fluids creates continuous low-frequency rumbling sounds. Black smokers generate louder noises due to their high fluid velocity. The fluid exiting the chimney creates chaotic turbulent mixing zones. This turbulence generates broadband noise across multiple acoustic sound frequencies. Mineral precipitation inside the chimney also creates tiny popping sounds. These microfractures produce sharp, high-frequency acoustic cracking noises underwater. Scientists deploy specialized hydrophones to record these deep ocean sounds. The recordings help researchers monitor the flow rate of the vents. Changes in the acoustic pitch indicate shifting fluid velocities inside. Some marine biologists believe local fauna use these deep sounds. Blind shrimp might navigate toward the vents by listening carefully. The ocean floor is never truly silent near a black smoker. The constant geological activity provides a steady, rhythmic background hum. This acoustic energy adds another layer of complexity to the ecosystem. Fact number 21 reveals the vast differences in vent acidity. Black and white smokers possess completely opposite chemical profiles. Black smoker fluids are known to be highly acidic. Their pH levels frequently drop to 2.8. This matches the strong acidity of common table vinegar. White smokers exhibit a completely different chemical nature entirely. Their deep-sea emissions are strongly alkaline in nature. The pH of white smokers ranges from 9 to 11. This resembles the high alkalinity of household cleaning ammonia. These extreme chemical differences create highly distinct biological habitats. Different microbial communities adapt to each specific pH environment. Acid-loving bacteria dominate the dark black smoker ecosystems. Alkaline environments support entirely different cellular life forms. This sharp chemical contrast dictates the surrounding food web. Seawater itself maintains a slightly alkaline pH of 8. The mixing zones create complex chemical gradients for life. Microbes exploit these gradients to generate vital. Fact number 22 explores the famous Lost City hydrothermal field. Scientists discovered this unique site in December 2000. It sits atop the Atlantis Massif underwater mountain range. The location rests deep within the mid-Atlantic Ocean. Researchers found it during a routine seafloor mapping expedition. The discovery stunned the global marine geology research community. They had never seen such massive carbonate structures before. Some towering mineral spires reach 60 meters in height. This makes them taller than most black smoker chimneys. The field covers an area of 500 square meters. It rests at a depth of roughly 800 meters. This is relatively shallow for a hydrothermal vent system. The towering structures look like giant ghostly white castles. They emit clear fluids instead of dark particulate clouds. The site remains continuously active for 30,000 years. This longevity far exceeds typical black smoker system lifespans. Black smokers usually collapse after just a. Fact number 23 explains the geological process of serpentinization. White smokers rely entirely on this unique chemical reaction. This geological process does not require underlying magma chambers. Black smokers need intense volcanic heat to function properly. White smokers instead generate heat through slow chemical changes. Cold seawater interacts directly with exposed oceanic mantle rock. This specific deep earth rock is known as peridotite. The seawater hydrates the olivine minerals inside the rock. This hydration alters the rock into a mineral called serpentinite. The chemical alteration releases significant amounts of thermal energy. Temperatures can rise to 260 degrees Celsius. This exothermic reaction warms the surrounding circulating ocean water. The process also produces large volumes of hydrogen gas. Hydrogen serves as a vital fuel source for deep microbes. Serpentinization causes the host rock to expand very significantly. The physical expansion creates new cracks in the ocean floor. More seawater enters these fresh deep fissures. Fact number 24 contrasts the chimney growth rates directly. Black smoker chimneys exhibit astonishingly rapid mineral growth rates. Minerals precipitate the moment hot vent fluid meets cold seawater. This immediate cooling forces dissolved metals to solidify instantly. A new black smoker can grow 30 centimeters daily. This equals roughly 9 meters of vertical growth annually. White smokers grow at a much slower, deliberate pace. Carbonate minerals build their structures layer by microscopic layer. A white smoker might grow just 1 centimeter per year. This drastic difference in speed affects their structural density. Fast-growing black smokers are highly porous and brittle. They often collapse under their own massive mineral weight. Slow-growing white smokers form dense, solid mineral deposits. Their gradual accumulation creates highly stable geological rock formations. Researchers once observed a black smoker rebuild itself completely. A submersible vehicle accidentally knocked over a small tower. The chimney reformed to its original height. Fact number 25 highlights the extreme temperature boundary differences. Temperature defines the boundary between black and white smokers. Black smokers emit the hottest fluids on the seafloor. Their internal temperatures frequently exceed 400 degrees Celsius. The intense ocean pressure prevents this superheated water from boiling. At normal sea level, water boils at 100 degrees. Deep ocean pressure changes the physical properties of water. White smokers operate at significantly lower thermal temperature ranges. Their fluid emissions typically remain between 40 and 90 degrees. This cooler temperature directly influences the mineral output composition. Heavy metals cannot remain dissolved in cooler ocean water. Therefore, white smokers do not emit iron or copper. The cooler fluids carry lighter elements like calcium and barium. These lower temperatures also create a more hospitable biological zone. Delicate organisms can live much closer to white smoker vents. Getting too close means instant death for deep-sea creatures. Thermal gradients around vents change drastically within. Fact number 26 explains the origin of the smoke color. The characteristic smoke color comes from suspended mineral particles. Black smokers spew dark plumes rich in iron sulfides. These metallic compounds are naturally pitch black in color. They absorb all light from deep-sea submersible lamps. The fluid looks exactly like thick industrial factory smoke. White smokers release completely different chemical compounds into the water. Their plumes contain high concentrations of barium and calcium. Silica is also a major component of white smoker fluid. These specific minerals form brilliant white crystalline solid particles. The particles reflect light, creating a milky white appearance. Sometimes the white smoke appears almost translucent or shimmering. This shimmer results from heat distorting the surrounding cold water. The optical effect resembles a mirage on a hot highway. As particles drift away, they slowly settle on the seafloor. Black smoker particles create dark metallic sediments over vast areas. White smoker particles leave pale, chalky deposits across the. Fact number 27 compares their vastly different operational lifespans. A typical black smoker field remains active for brief periods. Their lifespans usually range from 10 to 100 years. Underground magma chambers cool down rapidly over geological time. Tectonic shifts frequently choke off the subterranean plumbing systems. When the heat source dies, the black smoker goes dormant. The towering mineral chimneys eventually crumble into the dark abyss. White smokers boast a much greater geological longevity by comparison. The serpentinization process sustains them for tens of thousands of years. The Lost City field has vented continuously for 30 millennia. This immense stability provides a reliable haven for deep life. Evolution requires long periods of unbroken environmental stability to progress. White smokers offer this crucial uninterrupted time for biological development. Organisms can adapt and thrive without sudden catastrophic habitat loss. Dormant black smoker fields become silent graveyards of fallen rock. Scientists use radiometric dating to determine the age of extinct. Fact number 28 connects white smokers to the origin of life. Many astrobiologists focus their research on these unique alkaline environments. The conditions mirror the primordial oceans of early planet Earth. A billion years ago, our global oceans were slightly acidic. White smokers pumped highly alkaline fluids into this acidic sea. This created a natural proton gradient across the mineral walls. Modern living cells use exact proton gradients to generate energy. The porous carbonate structures act like natural cellular protective membranes. Microscopic mineral compartments could have trapped complex organic structural molecules. These tiny rock chambers concentrated amino acids and basic proteins. The constant flow of hydrogen gas provided necessary chemical fuel. Iron and nickel sulfides within the rocks acted as catalysts. They accelerated chemical reactions without requiring complex biological cellular enzymes. This hypothesis provides a logical bridge between chemistry and biology. Black smokers are generally considered too hot for early life. Their extreme temperatures would destroy fragile nascent organic compounds instantly. Fact number 29 maps their distinct locations across the seafloor. Black and white smokers occupy completely different regions of the crust. Black smokers typically sit directly on mid-ocean spreading ridges. They align perfectly with active volcanic tectonic plate boundary lines. Magma resides very close to the crustal surface in these zones. White smokers generally form much further away from these volcanic centers. They sit on older, cooler sections of the deep oceanic crust. Geologists call these distinct areas off-axis hydrothermal vent fields. The underlying rock must be exposed mantle peridotype for them. Tectonic faulting pulls the crust apart to expose this deep mantle. Therefore, white smokers are often found on massive underwater mountains. Locating off-axis white smokers is extremely difficult for marine scientists. They do not leave large thermal heat plumes in the water. Black smoker thermal plumes can be detected from many miles away. White smokers blend perfectly into the surrounding background ocean temperatures. Researchers must use high-resolution sonar to find their pale. Fact number 30 details the distinct biological communities of each vent. The biological communities differ vastly between the two main vent types. Giant tube worms dominate Pacific black smoker deep-sea vent ecosystems. They rely on symbiotic bacteria to process the toxic hydrogen sulfide. White smokers host entirely different biological populations in their quiet waters. The famous Lost City field lacks these massive tube worm colonies. Instead, thick microbial biofilms coat the towering white carbonate mineral chimneys. These biofilms look like pale slime covering the uneven rock surfaces. Tiny transparent snails graze slowly on these thick bacterial nutrient mats. The overall animal biomass at white smokers is noticeably much lower. Black smokers support dense, crowded forests of highly complex animal life. White smoker ecosystems are simpler, quieter, and deeply microscopic in scale. Methane-producing bacteria thrive in the hydrogen-rich white smoker fluids. These specific microscopic archaea are among the oldest living organisms on Earth. They perfectly match the ancient geological setting of the deep vents. Both environments prove that life easily adapts to extreme chemical. Fact number 31 reveals the first white smoker. Scientists discovered the first white smoker field recently. This major event occurred in December 2000. An expedition explored the mid-Atlantic ridge that year. They found a massive field of pale chimneys. Researchers named this area the Lost City Field. It sits near the Atlantis Massif underwater mountain. The discovery happened completely by accident during mapping. Cameras captured towering white structures emerging from darkness. No one expected to find this vent system. Previous expeditions only looked along active volcanic ridges. This new field rested 15 kilometers away instead. It rested on crust millions of years old. This location defied all previous hydrothermal vent models. Scientists realized deep-sea geology was vastly complex. The pale spires offered a new scientific frontier. Researchers quickly planned follow-up missions to this site. They returned with advanced submersibles 3 years later. Detailed mapping revealed a sprawling fact. Number 32 explores their lower fluid temperatures. White smokers operate at much lower temperatures overall. Black smokers routinely exceed 300 degrees Celsius. Some even reach 400 degrees under pressure. White smokers emit much cooler hydrothermal fluids instead. Their fluid temperatures range from 40 to 90. This is measured in Celsius, making them warm. The cooler temperature affects their physical appearance greatly. Minerals precipitate differently in these moderate thermal conditions. Black smokers eject superheated water filled with metals. These metals solidify instantly upon hitting cold seawater. White smokers release a gentler flow of fluid. This fluid lacks the dark iron sulfide particles. The lower heat prevents heavy metals from dissolving. Therefore, the escaping water appears cloudy and pale. Sometimes the fluid is completely clear and shimmering. You can see thermal distortion above the vents. The gentle heat creates a stable local environment. Many delicate organisms prefer these. Fact number 33 examines their unique chemical balance. Black smokers produce highly acidic hydrothermal vent fluids. Their pH levels often drop down to 2. This is similar to the acidity of vinegar. White smokers present the exact opposite chemical environment. Their fluids are strongly alkaline in deep oceans. The pH levels range from 9 to 11. This matches the alkalinity of household ammonia solutions. Such high alkalinity creates a challenging biological habitat. Normal ocean water maintains a neutral pH balance. It usually hovers around 8 on the scale. The extreme alkalinity of white smokers is fascinating. It causes specific chemical reactions in the seawater. Calcium carbonate precipitates rapidly in this basic environment. This chemical reaction builds the pale chimneys slowly. The alkaline water mixes gently with ocean currents. A distinct chemical gradient forms around the vents. Microbes have adapted to exploit this sharp gradient. They harvest energy from the fact number 34 details their fragile mineral composition. White smokers consist of completely different mineral compounds. Dark vents rely heavily on iron and copper. Pale vents are constructed primarily from carbonate minerals. They also contain high amounts of dissolved barium. Silicon and calcium dominate their fragile chimney structures. These elements create the characteristic white or gray. The minerals form delicate, porous walls over time. Barium sulfate creates beautiful crystalline formations underwater naturally. These crystals catch the light of submersible vehicles. The calcium carbonate is similar to limestone rock. It is the exact same material in seashells. These chimneys are incredibly fragile compared to others. Black smokers build dense, hard, Metallic chimney walls. White smoker walls crumble easily under slight pressure. Scientists must sample them with extreme care always. A robotic arm can easily crush the formations. The porous nature allows fluid to seep everywhere. This creates a massive sponge-like. Fact number 35 explains the hidden serpentinization process. White smokers are powered by a unique reaction. This geological process is known as serpentinization globally. It differs entirely from black smoker volcanic heating. Seawater penetrates deep into the ocean crust fractures. It encounters mantle rocks called peridotite down there. These deep rocks are rich in iron minerals. The water reacts chemically with the olivine compounds. This reaction alters the rock into serpentinite stone. Serpentinization is a highly exothermic chemical process naturally. It releases massive amounts of heat during alteration. This chemical heat warms the surrounding ocean water. No underlying magma chamber is required for this. The process also produces large volumes of hydrogen. Hydrogen gas dissolves into the warming hydrothermal fluids. This dissolved gas is crucial for deep life. The reaction also creates methane in the water. These dissolved gases rise back to the seafloor. They exit through the pale. Fact number 36 reveals their incredible geological longevity. White smoker fields have incredibly long active lifespans. Black smokers are relatively short-lived deep geological features. A typical black smoker lasts a few decades. Some may persist for a few hundred years. Volcanic activity shifts, cutting off their heat source. White smokers rely on slow, steady chemical reactions. The Lost City field demonstrates this remarkable longevity. Carbon dating of its chimneys reveals surprising ages. Scientists estimate the field is very old indeed. It has been active for over 30,000. Some models suggest up to 120. That equals 120,000 years total. The serpentinization process consumes vast amounts of rock. The Atlantis Massif provides an enormous mineral supply. This steady fuel source guarantees long-term vent stability. The stable environment allows complex ecosystems to evolve. Generations of microbes have thrived here undisturbed continuously. They survived multiple ice ages. Fact number 37 describes their staggering physical height. White smoker chimneys grow to truly massive heights. The gentle fluid flow allows for continuous building. Carbonate minerals precipitate slowly and stack up gradually. The largest structure sits in the Lost City. It is named the Poseidon Tower by researchers. This massive pillar stands 60 meters tall underwater. That equals the height of an 18-story building. It dwarfs almost all known black smoker chimneys. Black smokers usually collapse under their own weight. Their dense sulfide minerals become too heavy eventually. The lighter carbonate of white smokers builds higher. Poseidon features multiple spires and intricate flange structures. These flanges trap pools of warm alkaline water. The trapped water reflects the lights of submersibles. It looks like an upside-down shimmering silver lake. New growth constantly appears on the older structures. Tiny delicate cones form on the massive sides. These formations resemble wax dripping. Fact number 38 highlights their unique microscopic life. Life at white smokers differs from black smokers. Black smokers host giant tube worms and crabs. White smokers lack these large, complex animal communities. The high alkalinity and low metal content matter. They prevent many typical vent animals from surviving. Instead, white smokers are dominated by microscopic life. Thick microbial mats cover the pale carbonate chimneys. These communities are composed mostly of ancient archaea. Methanogens are the primary inhabitants of these vents. They consume the abundant hydrogen and carbon dioxide. They produce methane gas as a metabolic byproduct. Other microbes consume this methane for their energy. This creates a simple but highly effective ecosystem. Tiny snails and amphipods graze on these microbes. The biomass is smaller but incredibly dense locally. Scientists study these microbes to understand extreme survival. Their enzymes function perfectly in highly alkaline water. This biochemical adaptation is rare. Fact number 39 connects them to life's origins. White smokers are central to origin of life. Many scientists believe life began in such environments. The conditions match early Earth perfectly in theory. 4 billion years ago, the oceans were acidic. White smokers provided warm, alkaline, mineral-rich refuges then. The porous carbonate chimneys act like natural incubators. Their tiny compartments resemble primitive organic cell walls. These pores could concentrate essential organic molecules easily. The chemical gradient provides a natural energy source. Protons flow across the thin mineral pore walls. This mimics how modern living cells generate energy. Black smokers are considered too hot for this. Their extreme heat would destroy fragile organic compounds. The gentle warmth of white smokers is ideal. Amino acids can form and stabilize here safely. Researchers have simulated these conditions in modern laboratories. They successfully created basic organic building blocks there. This makes pale vents. Our fact number 40 maps their specific geographical distribution. The location of white smokers is highly specific. Black smokers sit directly on mid-ocean spreading ridges. They require the shallow magma found right there. White smokers are usually found off the axis. They sit kilometers away from the active rift. They form on tectonic fault lines called detachments. These faults pull the deep mantle rocks upward. This exposes the peridotite to the cold sea water. This specific tectonic setting is actually quite common. It occurs along slow-spreading ridges across the globe. However, finding these fields remains incredibly difficult today. They do not produce large acoustic water plumes. Black smokers create massive thermal anomalies in water. These anomalies are easy to detect with sonar. White smoker plumes are weak and disperse quickly. Scientists must rely on high-resolution bathymetric ocean mapping. They look for the specific dome-like mountain structures. Only a few active white. Fact number 41 details the mineral composition differences. Black and white smokers differ in their mineral makeup. Black smokers release fluids rich in heavy iron sulfides. These dark minerals create the signature thick black smoke. White smokers emit fluids containing lighter-colored mineral elements. Calcium and silicon dominate the white smoker fluid emissions. The mineral difference stems from varying deep fluid temperatures. Hotter fluids dissolve more heavy metals from surrounding rocks. Cooler fluids cannot carry these heavy iron compounds upward. Instead, they transport lighter elements directly to the ocean. The sudden cooling forces dissolved solids to crystallize instantly. Iron sulfides form dark particles immediately upon ocean contact. Silica and calcium form pale particles floating gently upward. This basic deep-sea chemistry dictates the vent colors. Scientists use these colors to map complex subsurface geology. The mineral deposits gradually build the towering chimney walls. Dark walls indicate a long history of extreme heat. Pale walls suggest a cooler, more highly fact number 42 explains the role of barium sulfate. Barium sulfate plays a crucial role in white smokers. This specific mineral gives the smoke its distinct color. Barium dissolves easily in warm underground hydrothermal vent fluids. It travels upward through deep cracks in the seafloor. Deep ocean seawater contains high levels of dissolved sulfate. When vent fluids meet seawater, a violent reaction occurs. Barium bonds directly with sulfate to form solid crystals. These microscopic mineral crystals are highly reflective and pale. They scatter the artificial light from deep diving submersibles. This light scattering creates the illusion of thick smoke. Barium sulfate also builds the physical vent chimney structure. It precipitates slowly around the outer edges of the vent. Over decades, it forms intricate and pale mineral spires. These structures are often much more fragile than black smokers. The crystals form highly porous walls that leak warm fluid. Scientists measure barium levels to track oceanic fluid. Fact number 43 explores the defining temperature thresholds. A specific temperature threshold clearly defines a black smoker. These deep vents must reach at least 300 degrees. Most black smokers operate around 350 degrees Celsius. At these extreme temperatures, deep sea water behaves very differently. The immense oceanic pressure completely prevents the water from boiling. It becomes a supercritical fluid with highly unique chemical properties. Supercritical water dissolves heavy rock metals with incredible efficiency. It aggressively strips iron and copper from the basaltic crust. White smokers cannot ever reach these extreme high temperature thresholds. They typically range from 2 to 300 degrees Celsius. Below 300 degrees, heavy earth metals remain securely trapped. The cooler fluid cannot transport iron to the ocean floor. Therefore, the escaping fluid entirely lacks the dark metallic particles. A sudden drop in temperature can change a vent's color. An active black smoker might slowly transition into white smoke. This slow thermal shift alters the local biological. Fact number 44 highlights the extreme pH differences. Black and white smokers exhibit massive chemical pH differences. Black smoker vent fluids are highly acidic and extremely corrosive. Their measured pH levels often drop as low as 2. This extreme acidity equals that of pure concentrated lemon juice. The acid easily dissolves surrounding rocks deep beneath the crust. White smokers present a completely different chemical profile down there. Their escaping fluids are generally highly alkaline in their nature. The average pH of white smokers can easily reach 11. This strong basicity resembles the chemistry of common household ammonia. Black smokers usually form over fresh and hot basaltic magma chambers. White smokers often form through a process called rock serpentinization. This slow reaction occurs when cold seawater meets deep mantle rocks. The complex chemical reaction generates gentle heat and alkaline fluids. It also constantly produces large quantities of pure hydrogen gas. Deep microbes adapt specifically to these distinct chemical oceanic environments. Acidic vents host tough organisms that tolerate high fact number 45 records the staggering physical heights. Black smoker mineral chimneys can reach truly staggering physical heights. The tallest known hydrothermal vent chimney was famously named Godzilla. It slowly grew off the dark coast of the Pacific Northwest. This massive towering structure reached 15 stories in vertical height. It measured exactly 45 meters directly from the rocky seafloor. Godzilla towered majestically over the surrounding Juan de Fuca Ridge. The thick chimney base spanned several meters across the bedrock. It took many long decades for minerals to build this monolith. Hot vent fluids constantly deposited heavy iron and sulfur compounds. The dark structure grew wider and taller with each passing year. Deep-sea ocean currents constantly pushed against the towering spire. The immense crushing pressure of the ocean held it together. Eventually, the giant structure became far too top-heavy to stand. In 1996, Godzilla finally collapsed entirely into broken rubble. Ocean scientists recorded the chaotic aftermath during a submersible dive. The fallen mineral debris created a massive and chaotic mound. New, smaller black chimneys immediately began growing. Fact number 46 examines the rapid chimney growth. The vertical growth rate of mineral chimneys is remarkably fast. Standard geological formations usually take millions of years to grow. Hydrothermal vents completely defy this slow geological time scale entirely. An active black smoker can grow 30 centimeters each day. This rapid pace equals roughly 9 meters of growth annually. Marine scientists have directly observed this rapid mineral accumulation process. They once intentionally cleared a vent orifice during an experiment. A brand new chimney began forming almost immediately upon clearance. Within just days, a fragile mineral tube appeared from nothing. The extraordinarily rapid growth relies on continuous hot fluid flow. If the internal rocky plumbing clogs, the vertical growth stops. Minerals chemically precipitate exactly at the boundary of hot and cold. This precise reaction creates a perfect upward building mechanism over time. The outer mineral walls cool and harden against the freezing seawater. The inner chimney walls remain hot and continuously channel rising fluids. This unique dual environment allows the rapid vertical. Fact number 47 details the brief active lifespan. The active flowing lifespan of a hydrothermal chimney is brief. Despite their massive physical size, they are temporary geological features. Most active black smokers remain flowing for only a few decades. Some smaller fragile vents might flow for just a few years. The underlying hot magma chamber eventually cools down and solidifies. When the deep heat source fades, the upward fluid flow stops. Earthquakes frequently alter the delicate subsurface rocky plumbing systems. A single violent tremor can shut down a massive vent completely. The sudden dark silence transforms the vibrant biological vent community. Without continuous chemical energy, the specialized bacteria quickly die off. The larger deep animals must migrate or face certain widespread starvation. A completely dead chimney stands silently as a cold mineral ghost. Over long periods, seawater slowly corrodes the dark sulfide structures. The towering silent spires gradually crumble back into the abyssal mud. This highly ephemeral nature makes studying them quite difficult for science. Researchers returning to a previously mapped vent often find it. Fact number 48 describes the chimney collapse process. The violent process of chimney collapse triggers massive ecological shifts. A heavy falling chimney crushes the delicate organisms at its base. Giant tube worms and clams are buried under heavy mineral debris. However, this sudden destruction creates brand new opportunities for deep life. The collapsed mineral rubble forms a highly porous mound on the seafloor. Warm vent fluids often continue to seep through this broken rock. New resilient microbial colonies quickly establish themselves in the fresh ruins. The wide rubble mound diffuses the hot fluids over a larger area. This diffusion creates a gentle, warm environment for many different species. Hungry scavengers arrive to consume the biological remains of crushed organisms. White crabs and deep-sea octopuses patrol the fresh mineral debris field. Eventually, brand new mineral spires begin growing upward from the mound. The pressurized fluid always finds the path of least resistance upward. A brand new black smoke arises from the ashes of the old. This endless cycle of destruction and rebirth heavily defines vent fact number 49 focuses on unique microbial mats. White smokers host highly unique and distinct biological microbial mats. These living mats form thick layers over the pale mineral structures. They look exactly like pale yellow or white fuzzy underwater blankets. The microbes living here rely on very different chemical energy sources. They primarily consume dissolved hydrogen sulfide and trapped methane gas. The highly alkaline environment requires highly specialized internal cellular machinery. These deep bacteria use incredibly ancient metabolic pathways to survive here. Many scientists believe these specific pathways mirror early life on Earth. The thick microbial mats provide a rich food source for grazing animals. Tiny sea snails and specialized blind shrimp feed directly on the bacteria. The much lower temperatures of white smokers allow thicker biological mat growth. Black smokers are often far too hot for such dense biological coverage. The sticky microbial mats also help cement the fragile white chimney walls. They naturally secrete sticky polymers that bind the loose mineral crystals together. This biological organic glue perfectly stabilizes the towering pale white spires. Deep life and geology work closely together to build fact number 50 reveals the famous Lost City discovery. The Lost City hydrothermal field completely redefined modern oceanic science. Marine researchers discovered this highly unique site in the year 2000. It sits near the mid-Atlantic ridge on a submerged underwater mountain. The massive Lost City consists entirely of towering pale white smokers. Some of these giant pale chimneys reach 60 meters in vertical height. They tower majestically over the surrounding rocky and barren underwater terrain. Unlike typical black smokers, the Lost City entirely lacks a magma source. The vent heat comes purely from the slow serpentinization of mantle rocks. This specific chemical reaction produces highly alkaline fluids and pure hydrogen gas. The escaping vent fluids reach temperatures of only 90 degrees Celsius. The pale mineral structures are composed almost entirely of solid calcium carbonate. The towering pale structures look exactly like melting wax in the dark. Dense microbial life thrives deep inside the highly porous white carbonate walls. The historic discovery proved that deep life does not require volcanic heat. It immediately opened exciting new possibilities for finding life on other planets. Frozen moons with rocky cores and subsurface oceans might fact number 51. Black and white smokers differ in mineral composition. Black smokers emit fluids rich in iron sulfides. These dark minerals create the characteristic black smoke. White smokers release completely different dissolved chemical compounds. Their fluids contain barium, calcium, and silicon. These elements form lighter-colored suspended mineral particles. The surrounding freezing ocean water cools the rising fluids. This rapid cooling triggers immediate mineral precipitation. Iron sulfides crystallize at much higher fluid temperatures. Barium and calcium compounds precipitate in cooler conditions. The resulting smoke color indicates the internal vent chemistry. Scientists use this visual cue during deep-sea dives. The mineral dust eventually settles on the dark seafloor. It creates thick metallic sediments over thousands of years. These heavy deposits hold vast amounts of valuable metals. Mining companies often target these ancient marine mineral beds. The distinct colors reveal complex geological processes below. Each chimney acts as a deep ocean chemical factory. The seafloor becomes painted in dark fact number 52. Temperature strictly dictates the type of smoker formed. Black smokers require extremely hot fluid emissions. Their internal temperatures usually exceed 350 degrees Celsius. Some black smokers reach 400 degrees Celsius. White smokers operate at significantly lower temperature ranges. Their fluids typically measure below 300 degrees Celsius. Often, white smokers emit fluids around 200 degrees. The heat source distance determines this temperature difference. Black smokers sit directly above shallow magma chambers. The water heats up intensely and rises rapidly. White smokers generally sit further away from the magma. Their fluids lose heat while traveling through crustal rock. Sometimes, black smokers slowly transition into white smokers. The underlying magma chamber gradually cools over time. This cooling shifts the mineral precipitation dynamics entirely. Lower temperatures prevent iron sulfides from dissolving into fluid. Only lighter minerals remain dissolved at these cooler temperatures. The vent slowly changes its output color. The thermal signature tells a story of fact number 53. The Lost City hydrothermal field represents a unique anomaly. Scientists discovered this massive white smoker system in 2000. It sits on the Atlantis Massif underwater mountain. This location is far from any active mid-ocean ridge. These white smokers do not rely on volcanic magma. Instead, they run on a chemical process called serpentinization. Seawater reacts directly with exposed mantle rock. This chemical reaction generates its own significant heat. The resulting hydrothermal fluids are highly alkaline. Their pH levels range from 9 to 11. The chimneys here consist mostly of calcium carbonate. They look like giant pale stalagmites reaching upward. The tallest structure towers 60 meters above the seafloor. Researchers named this massive calcium spire Poseidon. These vents produce abundant hydrogen and methane gases. These gases support thick biofilms of primitive bacteria. The Lost City remains active for over 30,000 years. This longevity far exceeds typical black smoker lifespans. It shows alternative pathways for fact number 54. Black smokers possess astonishingly rapid vertical growth rates. A new black smoker chimney can grow 30 centimeters daily. This equals roughly 9 meters of growth every month. White smokers grow at a much slower pace. Their lower temperatures cause slower mineral precipitation rates. Calcium carbonate white smokers might grow just centimeters annually. The rapid growth of black smokers creates fragile structures. The tall mineral spires frequently collapse under their own weight. Ocean currents also push against the towering mineral chimneys. A collapsed black smoker immediately begins rebuilding its structure. The hot fluid continues pouring from the broken stump. Fresh minerals precipitate upon contacting the cold seawater. A new chimney forms over the old foundation. Researchers once knocked over a chimney with a submersible. They returned a year later to check the site. A new 6-meter chimney had already replaced it. This rapid regeneration constantly changes the seafloor landscape. The vent fields remain in perpetual states. Fact number 55. Black and white smokers exhibit vastly different pH levels. Typical black smoker fluids are highly acidic. Their pH often drops to 2.8. This matches the acidity of commercial household vinegar. The high acidity helps dissolve heavy metals from rocks. Iron, copper, and zinc leach easily into acidic water. White smokers present a wider range of chemical profiles. Some white smokers are slightly acidic or neutral. Others, like the Lost City, are extremely alkaline. Alkaline white smokers cannot dissolve heavy metals effectively. Therefore, their fluids lack toxic metal concentrations. This chemical difference severely impacts local biological communities. Acidic black smokers host specialized extremophile organisms. These creatures evolved specific mechanisms to tolerate heavy metals. Alkaline white smokers support completely different microbial life. The microbes there thrive on hydrogen gas and methane. The ocean dilutes both fluids quickly upon mixing. However, the immediate vent environment remains chemically extreme. Nature adapts to both ends of the fact number 56. Anhydrite plays a crucial role in building black smokers. Anhydrite is a unique calcium sulfate mineral. It behaves differently than most common chemical compounds. Most minerals dissolve easier in hot water. Anhydrite actually becomes less soluble as temperatures rise. When cold seawater approaches a hot vent, it heats up. The calcium and sulfate in seawater combine instantly. They form a solid white ring of anhydrite. This fragile white ring forms the initial chimney foundation. Hot acidic fluids flow upward through this porous ring. Inside the ring, heavy metal sulfides begin to precipitate. The iron and copper sulfides coat the inner walls. Over time, the inner metallic layer thickens and hardens. The outer anhydrite layer slowly dissolves into the cold ocean. The final result is a solid metal sulfide tube. This process perfectly explains the chimney's structural integrity. White smokers do not follow this exact same mechanism. Their lower temperatures do not trigger immediate fact number 57. Not all hydrothermal fluids exit through towering chimneys. Massive amounts of fluid seep through the fractured seafloor. This phenomenon is known as diffuse flow. Diffuse flow areas surround both black and white smokers. The seeping fluids are much cooler than chimney emissions. Their temperatures usually range from 5 to 50 degrees Celsius. The fluid mixes with cold seawater beneath the crust. This mixing dilutes the chemicals before they reach the surface. Diffuse flow zones cover much larger areas than chimneys. They provide expansive habitats for deep-sea organisms. Most tube worms and clams live in these diffuse zones. They avoid the boiling temperatures of the main chimneys. The gentle flow delivers a steady supply of hydrogen sulfide. Microbes use this chemical to produce biological energy. Diffuse flow accounts for most of the vent heat loss. Scientists estimate it releases 90% of hydrothermal energy. The dramatic smoking chimneys are just a small visual component. The unseen diffuse flow truly sustains fact number 58. Hydrothermal vents generate distinct underwater acoustic signatures. Black smokers are exceptionally loud underwater environments. The high-pressure fluid creates intense broadband noise. The sound resembles a continuous, deep, roaring jet engine. Boiling fluids cause tiny bubbles to collapse violently. This process is known as acoustic cavitation. Cavitation produces high-frequency popping sounds near the vent. White smokers generate significantly quieter acoustic profiles. Their lower velocity fluids produce much less turbulence. The gentle flow creates a soft, low-frequency hum. Scientists use hydrophones to record these underwater sounds. The acoustic data helps locate hidden vent fields. Researchers can estimate fluid velocity just by listening. The pitch and volume indicate the vent activity level. Sound travels extremely well through the deep ocean water. These acoustic signals carry for several kilometers. Some marine animals might navigate using these sound beacons. The deep sea is not a silent world at all. Vent fields hum with fact number 59. Black and white smokers have vastly different operational lifespans. A typical black smoker chimney is highly transient. It usually remains active for just a few decades. The rapid mineral buildup eventually clogs the internal plumbing. The chimney chokes on its own massive mineral deposits. The fluid flow stops, and the chimney dies. Cold seawater quickly reclaims the dead metallic structure. White smokers often enjoy much longer functional lives. Their slower mineral precipitation prevents rapid internal clogging. The Lost City white smokers demonstrate this longevity clearly. Some individual white chimneys there have vented for millennia. Carbon dating reveals their ancient continuous activity. The underlying heat sources also dictate these lifespans. Black smokers rely on fast-moving, volatile magma chambers. Magma shifts easily, cutting off the heat supply. White smokers often rely on slow, steady rock cooling. This stable thermal process provides consistent energy for centuries. The seafloor holds graveyards of ancient fact number 60. Biological communities form distinct zones around different smokers. The temperature gradient creates strict boundaries for life. The hottest parts of black smokers host archaea. These single-celled organisms thrive at 100 degrees Celsius. They attach directly to the chimney walls. Moving slightly outward, the temperature drops significantly. Here, Pompeii worms build protective tubes on the rock. They tolerate temperatures around 80 degrees Celsius. Further away, the water cools to 20 degrees. Giant tube worms dominate this comfortable outer ring. White smokers exhibit entirely different biological zoning patterns. Their alkaline fluids support unique methane-consuming bacteria. Snails and crabs graze on these thick bacterial mats. The lack of toxic metals invites more diverse grazers. Each chimney type creates a highly specific microhabitat. The chemical composition dictates which microbes can survive. The microbes then determine which animals can follow. This creates a highly specialized deep ocean food web. Life adapts perfectly to the specific chemistry. Fact number 61 describes the massive vent temperature differences. Black and white smokers operate at vastly different temperatures. Black smokers emit fluids hotter than 300 degrees. Some black smokers reach 400 degrees Celsius easily. White smokers release much cooler deep ocean hydrothermal fluids. Their temperatures range from 40 to 90 degrees Celsius. This immense thermal gap dictates their unique chemical signatures. The extreme heat in black smokers dissolves heavy metals. Cooler white smoker fluids cannot carry these heavy metals. Dark iron sulfides precipitate in the boiling black smokers. White smokers produce lighter colored mineral particles instead. The surrounding ocean water sits near 2 degrees Celsius. The thermal gradient creates a massive shock to minerals. Rapid cooling forces dissolved elements out of the solution. This sudden precipitation builds the distinct ocean chimney structures. Scientists use temperature probes to classify new vent discoveries. The temperature variation creates diverse habitats. For fact number 62 highlights a completely unique mineral composition. White smokers lack the dark iron and copper sulfides. Instead, they expel fluids heavily rich in dissolved barium. Calcium is also highly abundant in white smoker emissions. These lighter elements create the signature pale smoke plumes. As the fluid mixes with cold seawater, minerals precipitate. Barium sulfate forms tiny white particles in the water. Calcium carbonate also crystallizes rapidly in the cold ocean. These white particles drift like snow in the abyss. The accumulated minerals build delicate and pale chimney structures. These chimneys look like ghostly towers in the dark. Silica deposits harden the structure over long time periods. The absence of heavy metals makes these vents less toxic. Certain deep organisms prefer this lighter mineral chemical environment. The mineralogy reflects the specific rocks beneath the crust. White smokers often form much further away from magma. The fluid travels through different geological layers. Fact number 63 covers the famous Lost City discovery. The Lost City hydrothermal field was discovered in 2000. An ocean expedition found it near the Mid-Atlantic Ridge. This discovery revealed an entirely new type of white smoker. The field sits 15 kilometers from the spreading axis. It rests on a massive mountain called the Atlantis Massif. Researchers spotted the pale towers using a towed camera. The chimneys here are composed entirely of calcium carbonate. They look completely different from typical black smoker vents. The Lost City vents do not rely on molten magma. Instead, they are driven by chemical reactions in deep rocks. This specific field has been active for 30,000 years. Typical black smokers only last for a few short decades. The discovery expanded our definition of hydrothermal vent systems. It proved that volcanic activity is not strictly necessary. The Lost City remains a crucial site for astrobiology research. Similar alkaline vents might exist on icy alien. Fact number 64 details drastically different vent acidity levels. Black smoker fluids are highly acidic by typical ocean standards. Their specific pH levels typically range between 2 and 3. This extreme acidity resembles pure lemon juice or stomach acid. The acidic nature helps dissolve heavy metals from the crust. In contrast, many white smokers are highly alkaline chemical environments. The Lost City hydrothermal fluids reach a pH of 11. This alkaline level is similar to household liquid ammonia solutions. The pH difference stems from the underlying deep geological reactions. Black smokers interact with basaltic rocks near active magma chambers. White smokers often interact with deep mantle rock geological formations. This extreme pH gradient creates a unique chemical energy source. The surrounding ocean water itself maintains a slightly alkaline pH. When vent fluids meet seawater, a sharp chemical gradient forms. Microbes exploit this sharp pH gradient to generate vital energy. They use the proton difference to power their cellular. Fact number 65 compares the lifespans of these vent structures. Black smoker chimneys are relatively short-lived geological ocean features. A typical black smoker might last 20 to 50 years. They grow rapidly but quickly become clogged with solid minerals. The intense heat and volatile magma also cause frequent collapses. White smokers possess a much longer and stable geological lifespan. Some white smoker fields remain active for many long millennia. The Lost City has vented continuously for 30,000 years. This longevity provides a highly stable environment for deep ecosystems. Slow and steady mineral deposition builds massive white chemical towers. The lack of violent magma shifts ensures long structural stability. A black smoker can grow 30 centimeters in one single day. White smokers might only grow a few centimeters every year. This slow growth creates highly dense and solid mineral structures. Researchers can study ancient climate records in white smoker layers. The layered minerals hold vital clues about past ocean. Fact number 66 explains the chemical engine behind white smokers. Serpentinization drives the thermal energy behind many white smoker vents. This is a purely chemical process occurring deep underground constantly. Seawater seeps down into exposed mantle rocks called solid peridotite. The water reacts with the mineral olivine inside the peridotite. This chemical reaction alters the rock into a mineral called serpentine. The transformation process releases a massive amount of thermal energy. This generated heat slowly warms the surrounding deep ocean water. The warmed water becomes highly buoyant and rises toward the surface. This rising fluid creates the beautiful white smoke vent plumes. Serpentinization also produces highly concentrated hydrogen gas bubbles underwater. Hydrogen is a crucial fuel source for deep ocean microbes. The reaction does not require any underlying active magma chamber. This allows white smokers to form far from volcanic ridges. This mechanism might warm the dark oceans of distant moons. Enceladus and Europa likely host similar serpentinization reactions. Deep fact number 67 reveals the staggering heights of white smokers. The largest known black smokers reach about 30 meters tall. White smokers can grow much taller than their darker counterparts. One famous white smoker tower is formally named the Poseidon. The Poseidon structure stands an impressive 60 meters tall underwater. It is roughly the height of an 18-story human building. These massive carbonate towers vaguely resemble melted wax candle formations. They feature intricate flanges and incredibly delicate mineral overhang structures. The porous carbonate walls trap warm hydrothermal fluids inside them. This creates isolated microenvironments for specialized bacterial colonies to thrive. The towers grow steadily over thousands of uninterrupted dark years. Their pale surfaces brilliantly reflect the lights of deep submersibles. Water flows through thousands of tiny interconnected mineral fluid channels. These channels act exactly like veins in a living organism. The sheer size of these towers alters local deep ocean currents. They create massive physical obstacles on the otherwise flat ocean floor. Fact number 68 explains the role of the mineral anhydrite. Anhydrite plays a crucial role in forming new smoker chimneys. This unique mineral is primarily composed of simple calcium sulfate. Most minerals dissolve much more easily in hot water solutions. Anhydrite becomes less soluble as the water temperature rapidly rises. It dissolves in cold seawater but solidifies in extreme heat. When superheated vent fluid hits cold seawater, solid anhydrite precipitates. It forms the initial fragile mineral shell of a new chimney. This thin shell separates the hot fluid from the cold ocean. The anhydrite wall provides a framework for other heavy minerals. Iron and copper sulfides then deposit inside this protective shell. These darker minerals build the permanent black smoker central structure. Without the initial anhydrite shell, permanent chimneys could not grow. Anhydrite acts as the crucial deep underwater architectural building scaffolding. If the vent stops flowing, the chimney rapidly cools down. The cold ocean water then slowly dissolves the outer. Fact number 69 contrasts the biological communities of both vents. Black and white smokers host entirely different biological ocean ecosystems. Black smokers are heavily dominated by extreme thermophilic heat bacteria. These organisms thrive in temperatures exceeding 80 degrees Celsius easily. They consume hydrogen sulfide to produce vital organic carbon compounds. Giant tube worms and blind shrimp crowd around black smokers. White smokers support a much different type of deep ecosystem. The alkaline fluids in white smokers completely lack hydrogen sulfide. Instead, they are incredibly rich in dissolved methane and hydrogen. Methanosarcinoarchaea dominate the white smoker microscopic biological bottom communities. These ancient microbes consume methane to survive the eternal darkness. Instead, the biomass is almost entirely microscopic and safely hidden. Thick microbial biofilms coat the pale carbonate chimney outer walls. Tiny ocean snails and small amphipods graze on these bacterial mats. The white smoker ecosystem is simpler but incredibly ancient biologically. Scientists believe this ecosystem closely resembles early Earth life. Fact number 70 describes the acoustic properties of hydrothermal vents. Hydrothermal vents generate distinct and powerful acoustic sound wave signals. The violent mixture of fluids creates deep underwater sound waves. Black smokers produce a continuous low-frequency rumbling ocean noise. The sound originates from the rapid expansion of hot fluids. Boiling water creates tiny bubbles that collapse under immense pressure. This violent cavitation process generates a steady acoustic deep hum. White smokers produce a much quieter and softer acoustic profile. Their cooler temperatures prevent the violent boiling process almost entirely. The gentle flow of white smokers whispers into the dark. Scientists use sensitive hydrophones to listen to these deep-sea vents. Acoustic monitoring helps track the flow rates of the chimneys. Changes in the sound indicate shifting underground molten magma chambers. The vent noise acts as an acoustic beacon in the darkness. Each individual vent field possesses a totally unique acoustic signature. Listening to the deep ocean reveals a hidden underwater. Fact number 71. Black and white smokers exhibit vastly different temperature profiles. Black smoker fluids can reach 400 degrees Celsius. The surrounding seawater remains near 2 degrees Celsius. This extreme contrast creates massive thermal gradients underwater. White smokers operate at much cooler temperature ranges. Their hydrothermal fluids rarely exceed 300 degrees. Often, they hover around 250 degrees. This thermal variation stems from their subsurface plumbing systems. Black smokers draw heat directly from shallow magma chambers. White smokers originate further away from active volcanic centers. Their fluids mix extensively with cooler seawater before venting. This subsurface mixing drops the overall fluid temperature significantly. The cooler temperatures dictate the physical appearance of the plume. Lower heat prevents the precipitation of dark, heavy metals. Instead, lighter minerals dissolve into the surrounding oceanic waters. These thermal profiles shape the entire surrounding deep ecosystem. Deep-sea organisms must adapt to these specific thermal zones. Scientists map these thermal zones using remote fact number 72. The defining colors of these chimneys come from specific minerals. Black smokers expel fluids rich in dissolved iron sulfides. They also contain high concentrations of copper and zinc. When superheated fluid hits cold sea water, minerals instantly precipitate. The sudden cooling forms tiny, dark, solid mineral particles. These dark particles create the illusion of thick black smoke. White smokers release a completely different chemical mixture underwater. Their fluids contain abundant barium, calcium, and silicon compounds. These specific elements form pale, light-colored mineral precipitates. Barium sulfate is a primary component of white smoker plumes. Silica also contributes heavily to the pale, cloudy appearance. The absence of iron sulfides keeps the plume looking white. Mineral composition directly affects the structural integrity of chimneys. Iron sulfides build dense, highly rigid vertical tower structures. Calcium and barium create softer, more porous chimney walls. Researchers analyze these minerals to understand subsea floor geological processes. The chemical signatures reveal the exact composition of oceanic crust. Each vent system acts as a window fact number 73. The acidity levels differ drastically between the two vent types. Black smoker fluids are typically highly acidic in nature. Their pH levels often drop as low as 2.8. This extreme acidity resembles the strength of commercial vinegar. The low pH allows the fluid to dissolve heavy metals. Acidic water strips iron and copper from the surrounding rocks. White smokers present a completely opposite chemical environment. Many white smokers produce highly alkaline hydrothermal fluids. Their pH levels can reach between 9 and 11. This alkalinity resembles the chemical makeup of household ammonia. The high pH prevents the dissolution of heavy metals. Instead, it favors the transport of lighter chemical elements. These contrasting pH levels create entirely different chemical reactions. The mixing of alkaline fluids with seawater creates mineral gradients. These gradients generate tiny electrical currents within the rock pores. Some scientists believe these currents could power primitive biological processes. The pH difference dictates which microorganisms can survive nearby. Acidophilic bacteria thrive around the fact number 74. Black and white smokers grow into distinct physical structures. Black smoker chimneys can grow to massive, towering heights. Some reach up to 60 meters above the deep seafloor. Their iron sulfide walls are thick, dense, and structurally sound. They form singular, tall spires resembling industrial factory smokestacks. White smokers generally form much smaller, delicate chimney structures. They rarely exceed heights of 10 to 15 meters. Their walls consist of highly porous, fragile carbonate minerals. Instead of tall spires, they form wide, intricate mounds. These mounds contain thousands of tiny, interconnected fluid channels. The fragile nature makes white smokers vulnerable to physical damage. Ocean currents can easily erode their soft mineral exteriors. Black smokers grow rapidly, sometimes several centimeters per day. White smokers accumulate mineral mass at a much slower pace. Their slow growth creates complex, sponge-like internal mineral networks. These internal networks provide extensive surface area for microbial colonization. The structural variations offer different habitats for marine life. Tall black smokers attract free-swimming organisms to fact number 75. The discovery of these vents happened in distinct historical phases. Scientists first discovered black smokers in 1979. The Alvin submersible found them on the East Pacific Rise. This initial discovery revolutionized modern marine biology and geology. Researchers were shocked by the dark, mineral-rich, superheated plumes. White smokers remained hidden from human observation for much longer. Their cooler temperatures made them harder to detect with sensors. They also lacked the massive thermal anomalies of black smokers. The first major white smoker field was found much later. Scientists mapped the famous Lost City field in the year 2000. This discovery occurred on the Mid-Atlantic Ridge during a routine survey. The 21-year gap between discoveries highlights ocean exploration difficulties. Deep-sea navigation requires highly specialized acoustic mapping equipment. White smokers often blend into the surrounding pale seafloor topography. Their subtle chemical signatures require precise water sampling techniques. Today, autonomous underwater vehicles scan the ocean floor systematically. They use chemical sensors to detect faint fact number 76. Different animal communities colonize black and white smoker environments. Black smokers host massive clusters of giant tube worms. These worms rely on symbiotic bacteria to process hydrogen sulfide. Swarms of blind shrimp also gather around black smoker chimneys. They feed directly on the thick bacterial mats growing there. White smokers support a distinctly different ecosystem of creatures. Giant tube worms are notably absent from white smoker fields. Instead, dense populations of small snails dominate the porous rocks. Transparent amphipods navigate the delicate, pale mineral structures safely. The microbial base of the food web differs completely here. White smoker bacteria process methane rather than hydrogen sulfide. This methane-based metabolism supports a slower-paced biological community. The overall biomass around white smokers is generally much lower. However, the biodiversity often exceeds that of black smoker fields. Many unique species exist only within specific white smoker mounds. The cooler, alkaline waters provide a stable, long-term biological refuge. Organisms here face fewer extreme temperature fluctuations than elsewhere. This stability allows highly specialized evolutionary adaptations. Fact number 77. The Lost City is the most famous white smoker field. It sits near the summit of the Atlantis Massif underwater mountain. The field rests roughly 800 meters below the surface. Its central chimney stands nearly 60 meters tall today. Scientists named this towering white structure the Poseidon complex. The chimneys here consist entirely of calcium carbonate minerals. They look like pale, ghostly stalagmites rising from the dark floor. The fluids venting from Lost City are highly alkaline. They measure around pH 9 to 11 consistently year-round. Fluid temperatures remain steady between 40 and 90 degrees Celsius. This environment produces abundant amounts of abiotic methane gas. The methane forms without any biological decay processes involved. The field has remained active for at least 30,000 years. This incredible longevity far surpasses typical black smoker systems. Black smokers usually collapse or clog within a few decades. The Lost City provides a unique window into sustained geological processes. Its continuous activity creates massive, terraced mineral. Fact number 78. A unique chemical reaction drives white smoker fluid production. This geological process is known scientifically as serpentinization. It occurs when seawater meets mantle rock called peridotite. Peridotite is rich in the mineral olivine, which reacts with water. This chemical reaction fundamentally alters the rock's basic structure. It transforms the rigid peridotite into a softer rock called serpentinite. The serpentinization process releases massive amounts of thermal energy. This exothermic reaction creates the heat found in white smokers. It does not require underlying magma chambers to generate heat. The reaction also produces high volumes of pure hydrogen gas. This hydrogen mixes with carbon dioxide in the surrounding water. Together, they form simple organic molecules like methane and formate. This abiotic synthesis of organic compounds fascinates chemical oceanographers. It proves that geology alone can create the building blocks of life. Serpentinization occurs deep within the Earth, slowly spreading tectonic plates. The process causes the surrounding rocks to expand and crack. These cracks create new pathways for seawater. Fact number 79. The operational lifespans of these two vent types differ greatly. Black smokers are geologically short-lived, volatile deep-sea features. A typical black smoker chimney lasts only 10 to 20 years. The rapid precipitation of iron sulfides quickly clogs their internal channels. Once the plumbing clogs, the internal fluid pressure builds rapidly. Eventually, the superheated fluids force a new pathway through the crust. The old black smoker chimney goes cold and slowly crumbles. Surrounding biological communities must migrate to survive the vent's death. White smokers operate on a completely different geological timescale. Their slower mineral precipitation rates prevent rapid channel blockages. The heat source driving them remains stable for thousands of years. Carbonate chimneys can actively vent fluids for tens of thousands of years. This immense stability allows massive mineral deposits to accumulate safely. Some white smoker mounds span hundreds of meters across the seafloor. Their long lifespans create permanent oases in the deep ocean desert. Microbial communities evolve slowly within these enduring mineral fortresses. Scientists use radiometric dating to determine the exact age. Fact number 80. White smokers hold vital clues to the origin of life on Earth. Early Earth possessed oceans vastly different from our modern seas. The ancient oceans were highly acidic and rich in dissolved iron. Alkaline fluids from white smokers would have mixed with this acidic water. This mixing created natural proton gradients across the porous chimney walls. These gradients mirror the energy production methods of modern living cells. Tiny mineral compartments within the chimneys acted as primitive cell walls. They trapped complex organic molecules generated by the serpentinization process. These confined spaces allowed organic chemicals to concentrate and interact safely. Over millions of years, these interactions grew increasingly complex and organized. Many astrobiologists believe life began in environments exactly like the lost city. The stable, warm, alkaline conditions provided the perfect chemical nursery. Similar hydrothermal systems might exist on icy moons like Enceladus. NASA studies white smokers to guide future extraterrestrial exploration missions. Understanding these deep-sea vents helps us search the cosmos for life. The pale chimneys bridge the gap between geology and fact number 81. White smokers owe their pale color to specific minerals. Silica is the primary component of these ghostly chimneys. This mineral dissolves easily in warm alkaline vent fluids. The fluid temperatures range from 50 to 90 degrees. These temperatures are much lower than black smoker emissions. As the warm fluid meets cold sea water, silica precipitates. It forms delicate white structures resembling frozen crystal towers. Barium and calcium also contribute to the pale appearance. These minerals create highly porous walls within the chimney. The porous structure allows seawater to slowly seep inward. This creates complex chemical gradients inside the mineral matrix. Microbes exploit these tiny porous chambers for chemical energy. Silica deposits grow much slower than iron sulfide structures. White smokers might grow only centimeters per year. Their slow growth creates highly stable deep ocean habitats. These quiet environments support unique microscopic biological communities. Researchers study these silica structures to fact number 82. Black smokers have surprisingly short geological lifespans overall. A typical chimney remains active for only a few decades. Some structures might last up to 100 years. The intense heat eventually alters the underlying rock structure. Magma chambers beneath the ocean floor slowly shift position. This movement cuts off the vital heat supply below. Mineral deposits also clog the internal plumbing over time. The central channel becomes choked with solid iron sulfide. Fluid flow gradually slows down and eventually stops completely. Without the outward pressure, the chimney begins to decay. Ocean currents slowly erode the towering black mineral spires. The unique biological community loses its primary energy source. Tube worms and crabs migrate to find new vents. Most organisms will perish when the black smoker dies. Scientists track these life cycles using remote acoustic monitoring devices. They observe how quickly a thriving ecosystem becomes barren. New chimneys will eventually form along the fact number 83. The Lost City hydrothermal field was discovered recently. Scientists found this unique white smoker system in 2000. It sits on the Atlantis Massif in the Atlantic. This location is far from any active volcanic ridge. The discovery challenged existing theories about hydrothermal vent formation. These white chimneys tower up to 60 meters high. They are formed through a process called serpentinization. Seawater reacts directly with exposed mantle rock called peridotite. This chemical reaction generates both heat and alkaline fluids. The fluid reaches temperatures around 90 degrees Celsius here. Calcium carbonate precipitates to build the massive white towers. The structures look like giant limestone stalagmites underwater. Carbon dating shows the field is 30,000 years old. This makes it vastly older than typical black smokers. The lost city supports life without relying on magma. Methane and hydrogen fuel the microbial communities living here. Researchers believe similar systems might exist on icy moons. This field remains a crucial site. Fact number 84. Black smoker walls contain extreme temperature gradients inside. Inner fluid boils at nearly 400 degrees. The surrounding seawater sits at a freezing 2 degrees. The mineral wall separating them is incredibly thin. Sometimes this barrier is only 2 centimeters in thickness. This creates a staggering temperature drop across the wall. The gradient can exceed 200 degrees per centimeter. Different minerals crystallize at very specific temperature zones inside. Copper iron sulfide forms closest to the boiling interior. Zinc sulfide precipitates in the slightly cooler middle layers. Calcium sulfate and silica dominate the cold outer shell. Microbes inhabit specific thermal zones within this mineral gradient. Some bacteria thrive at exactly 80 degrees Celsius inside. Others prefer the cooler 40-degree outer wall regions. This creates a layered biological cake within the rock. Scientists carefully measure these gradients using titanium thermal probes. Understanding these zones helps explain deep sea fact number 85. Black smokers actively deposit precious metals on the seafloor. The superheated fluids dissolve metals deep within the crust. Magma chambers provide a rich source of trace elements. As the fluid erupts, it carries dissolved gold upward. Silver and copper are also transported in large quantities. The sudden cooling forces these metals to precipitate out. They become trapped within the growing iron sulfide chimney. Some vent deposits contain up to 10 parts per million gold. This concentration rivals many commercial gold mines on land. A single large chimney can hold many tons of copper. Over thousands of years, massive sulfide deposits accumulate here. Ancient vent deposits are currently mined on dry land. Cyprus was a famous source of copper in antiquity. Those ancient copper mines were once active black smokers. Tectonic forces pushed those ancient sea floors above water. Modern deep-sea deposits remain largely untouched by humans. The extreme depth makes commercial extraction incredibly difficult. Fact number 86. Vents produce distinct acoustic signatures in the abyss. Black smokers are not silent structures on the seabed. The high-pressure fluid creates a continuous roaring sound. This noise resembles a jet engine running underwater constantly. The sound frequency ranges from 10 to 500 Hz. Boiling fluids create tiny bubbles that collapse under pressure. This cavitation process generates sharp acoustic popping noises nearby. The towering mineral chimneys also act like giant organ pipes. Different chimney shapes produce entirely different acoustic resonant frequencies. White smokers produce much softer and much quieter hissing sounds. Their lower fluid velocity prevents violent cavitation from occurring. Marine biologists think some animals might use this sound. Blind shrimp could navigate toward vents using acoustic cues. Hydrophones record these deep-sea symphonies for scientific study. The ambient noise helps researchers locate new vent fields. We now turn to theories about the origin. Fact number 87. White smokers are central to origin of life models. Scientists call this the alkaline hydrothermal vent hypothesis. Early Earth had highly acidic and iron-rich oceans. White smokers pumped warm alkaline fluids into this ocean. This created a proton gradient across the mineral walls. Porous rocks provided tiny compartments for early chemical reactions. These microscopic chambers acted like primitive biological cell walls. The natural electrical gradients could power early chemical synthesis. Carbon dioxide and hydrogen reacted, forming simple organic molecules. Iron and nickel sulfides acted as natural chemical catalysts. This environment did not require sunlight for energy production. It perfectly mimics the energy mechanisms of modern cells. Black smokers are considered too hot for early life. Their extreme temperatures would destroy fragile, complex organic molecules. The gentle warmth of white smokers provided safe havens. Many researchers believe life began in these quiet structures. This theory shifts focus away from shallow fact number 88. Some deep vents emit water in a supercritical state. This occurs when pressure and temperature cross specific thresholds. The critical point for seawater is 298 atmospheres. The temperature must exceed 407 degrees Celsius. At these extremes, water loses distinct liquid and gas phases. It becomes a dense fog with unique physical properties. Supercritical water diffuses through rock like a thin gas. Yet it dissolves heavy metals like a thick liquid. The Turtle Pit's vent field features these extreme conditions. It is located on the Mid-Atlantic Ridge System. Fluids here reach 464 degrees Celsius. This is the hottest water ever measured on Earth. The fluid does not boil due to the crushing pressure. It shoots out of the chimney completely invisible initially. It only turns black when it hits cold seawater. Studying supercritical fluids helps engineers design better fact number 89. A dying black smoker undergoes a dramatic ecological succession. When hot fluid stops flowing, the environment changes. Giant red tube worms are usually the first to perish. Their symbiotic bacteria lack the necessary hydrogen sulfide fuel. Without chemical energy, the entire food web collapses. Predatory crabs and blind fish slowly abandon the structure. The towering mineral chimney becomes a cold, silent ghost. This dead structure does not remain completely empty. A new community of deep-sea organisms soon arrives. Cold water corals anchor themselves to the solid sulfides. Sponges slowly colonize the rough exterior of the chimney. Filter-feeding anemones attach to the highest mineral peaks. They use the elevation to catch passing ocean currents. Scavenging worms feed on the decaying remains of tube worms. The chimney transforms from a chemical oasis into a reef. This secondary ecosystem can persist for many centuries. The mineral tower slowly oxidizes in the fact number 90. Extinct hydrothermal vents are targets for future ocean mining. These massive sulfide deposits hold vast untapped mineral wealth. Active vents are generally protected by international environmental agreements. Dead chimneys do not host rare chemoautotrophic biological communities. Mining companies view them as safer targets for extraction. Robotic crawlers are designed to crush these ancient towers. The crushed ore would be pumped to surface vessels. A single site could yield millions of tons of copper. Zinc and rare earth elements are also highly sought. However, biologists warn about potential damage to deep ecosystems. The mining process creates massive plumes of toxic dust. These sediment clouds could smother nearby living vent fields. The noise might disrupt whales and deep-diving mammals. Cold water corals living on dead vents would be destroyed. The International Seabed Authority regulates these deep ocean zones. They are currently drafting rules for future extraction projects. The debate over deep-sea mining remains. Fact number 91 measures the incredible fluid output. Hydrothermal vents release massive volumes of heated fluids. A single black smoker discharges fluids very rapidly. Flow rates often reach 2 meters per second. This translates to hundreds of liters every minute. Over a single year, the volume is staggering. One chimney can expel millions of cubic meters. These fluids mix quickly with the surrounding seawater. The rapid fluid mixing causes immediate mineral precipitation. Scientists use acoustic instruments to measure these flows. Doppler sonar systems track the rising fluid velocities. Researchers deployed these sensors extensively in 2000. They discovered vast differences between individual vent structures. Some chimneys produce slow, steady chemical seeps instead. White smokers generally display much lower flow rates. Their fluids trickle out at mere centimeters per second. This fluid flow disparity creates diverse local microenvironments. Deep ocean currents eventually disperse these. Fact number 92 reveals the ocean chemistry buffering. Hydrothermal vents regulate global ocean chemistry over time. They act as a massive chemical buffering system. Cold seawater circulates through the oceanic crust constantly. This process alters the chemical composition of seawater. Magnesium is completely removed from the circulating water. The ocean crust absorbs this dissolved magnesium entirely. Meanwhile, calcium is added to the emerging fluids. This exchange maintains the chemical balance of seawater. Without these vents, ocean chemistry would change drastically. Rivers constantly dump dissolved minerals into the oceans. Hydrothermal activity removes many of these excess minerals. This cycle has operated for billions of years. The entire ocean volume cycles through the crust. This complete cycling takes about 10 million years. Scientists calculated this massive chemical exchange rate recently. Isotope studies confirmed the exact duration of cycling. The vents prevent the sea from. Fact number 93 details the rising chemical clouds. Vent fluids create massive plumes in the dark ocean. These plumes rise hundreds of meters above chimneys. They eventually reach a level of neutral buoyancy. Ocean currents then carry these chemical clouds horizontally. Some plumes travel thousands of kilometers from vents. Scientists track these plumes to discover new fields. They measure slight changes in water temperature anomalies. Optical sensors detect tiny suspended mineral particles nearby. Chemical sensors look for traces of dissolved iron. Helium-3 isotopes provide another reliable tracking marker. This rare isotope originates from the Earth's mantle. Its presence strongly indicates nearby hydrothermal vent activity. In 1993, researchers tracked a giant plume. It stretched across the southern Pacific Ocean basin. The plume dispersed vital nutrients across barren waters. These iron-rich waters fertilize distant surface phytoplankton populations. Deep-sea vents thus support shallow. Fact number 94 examines the ancient fossilized vents. Hydrothermal vents might be the true birthplace of life. Scientists found ancient fossilized vents in northern Quebec, Canada. These rock formations are incredibly ancient deep geological structures. They date back over 3.7 billion years. The fossils contain tiny tubes and metallic filaments. These microscopic structures resemble modern vent bacteria remnants. Early Earth was a harsh, heavily bombarded planet. Their alkaline fluids react with acidic ancient seawater. This reaction generates natural proton gradients across rocks. Cellular life uses identical gradients for energy production. This similarity strongly supports the vent origin hypothesis. Researchers published these groundbreaking fossil findings very recently. The discovery revolutionized our understanding of early evolution. Life likely began in absolute darkness deep underwater. Sunlight was not required for the first fact. Number 95 connects vents to extraterrestrial oceans. Hydrothermal vents guide our search for extraterrestrial life. Several moons in our solar system hide oceans. Jupiter's moon Europa contains a vast subsurface ocean. Saturn's moon Enceladus also harbors deep liquid water. Thick ice crusts cover both of these worlds. Sunlight cannot penetrate these massive icy outer shells. However, tidal forces generate internal heat within them. This internal friction likely powers alien hydrothermal vents. The Cassini spacecraft detected silica particles from Enceladus. These specific particles only form in hot water. They strongly suggest active alkaline hydrothermal vents exist. Earth bacteria use hydrogen as a primary fuel. Alien microbes might survive using similar chemical processes. NASA studies Earth vents to design space probes. Autonomous submarines will eventually explore these distant oceans. They will look for chemical signatures of life. Black and white smokers provide perfect fact. Number 96 explores the underwater acoustic signatures. Hydrothermal vents generate distinct acoustic sound signatures underwater. The deep ocean is rarely a silent place. Boiling fluids create continuous low-frequency rumbling noises. Mineral precipitation produces subtle cracking and popping sounds. Scientists lower hydrophones to record these vent symphonies. Each vent field produces a unique acoustic fingerprint. The sound changes based on fluid flow rates. Temperature fluctuations also alter the emitted acoustic frequencies. Researchers use sound to monitor vent activity remotely. In 2006, hydrophones captured an eruption. The East Pacific rise suddenly became highly active. Sound waves travel incredibly far through deep water. This allows distant monitoring of isolated vent fields. Marine animals might use these sounds for navigation. Blind shrimp could potentially hear the venting fluids. This auditory cue would help them find habitats. Acoustic research reveals the hidden dynamics of vents. The soundscape provides continuous data. Fact number 97 addresses the deep-sea mining. Hydrothermal vents face significant threats from human activities. Deep-sea mining companies target these mineral deposits. Black smokers create massive sulfide deposits over millennia. These deposits contain copper, zinc, gold, and silver. The concentration of precious metals is extremely high. Mining machines would destroy the fragile chimney structures. This destruction would instantly eradicate unique biological communities. The mining process also generates massive sediment plumes. These artificial plumes could smother nearby filter feeders. Vent ecosystems grow very slowly in the dark. Recovery from mining damage could take many decades. Some endemic species might face immediate global extinction. Scientists strongly advocate for vent ecosystem protection measures. They emphasize the immense biological value of vents. Genetic resources hold more potential than extracted metals. Medical discoveries often originate from extreme vent organisms. Preserving these habitats is crucial for fact number 98 discusses the international conservation laws. International laws govern the protection of hydrothermal vents. The International Seabed Authority manages deep ocean resources. They regulate areas beyond national maritime jurisdiction boundaries. This organization issues exploration contracts to various nations. However, environmental guidelines are still actively being developed. Some countries protect vents within their exclusive zones. Canada created the Endeavour Hydrothermal Vents Marine Area. This sanctuary was established in 2003. It protects a highly active ridge ecosystem completely. Portugal also safeguards the Azores hydrothermal vent fields. Scientific research is carefully permitted and heavily monitored. Global treaties aim to preserve marine biodiversity effectively. The United Nations recently drafted high seas treaties. These agreements address deep-sea conservation challenges directly. Protecting vents requires unprecedented global cooperation and trust. The ocean floor belongs to all of humanity. Shared responsibility ensures the survival of fact number 99 highlights future vent exploration technology. Future technology will revolutionize hydrothermal vent scientific exploration. Artificial intelligence helps identify new vent field locations. Machine learning algorithms process vast oceanographic data sets. They predict vent locations based on geological features. Autonomous underwater vehicles map the seafloor with precision. These robots operate without direct human remote control. New sensors detect chemical traces with extreme sensitivity. Laser spectrometers analyze vent fluid composition in milliseconds. Three-dimensional imaging creates perfect digital vent replicas. Virtual reality allows scientists to explore vents remotely. This reduces the need for expensive manned submersibles. Genetic sequencing occurs directly on the ocean floor. Robotic labs analyze microbial DNA without surfacing samples. This prevents biological degradation caused by pressure changes. Technology brings the deep sea into our laboratories. The next decade promises incredible deep ocean discoveries. We have only mapped a fraction of fact number 100 reveals global planetary connections. Hydrothermal vents connect deeply to global planetary systems. They are not merely isolated deep-sea anomalies. Vents transfer immense heat from the Earth's interior. This thermal energy influences deep ocean water circulation. The chemical emissions alter marine food web dynamics. Iron from vents fertilizes distant surface ocean regions. This fertilization affects global atmospheric carbon dioxide levels. Vent bacteria consume massive amounts of methane gas. This prevents greenhouse gases from reaching the atmosphere. The tectonic plates constantly shift and create vents. This geological cycle sustains life across the planet. From the fiery mantle to the sunlit surface, every part of the Earth remains intricately connected. It expanded our definition of habitable planetary zones. Life finds a way in the darkest depths. The black and white smokers stand as testaments. They prove the incredible resilience of we have reached the end of our journey. 100 facts about black and white smokers. We explored the deepest trenches of our oceans. We witnessed boiling water meeting freezing abyssal currents. We marveled at creatures living in absolute darkness. Giant tube worms thrive without a single sunbeam. Ancient microbes consume rocks to generate vital energy. These ecosystems challenge everything we thought we knew. They show us the boundless adaptability of life. Yet it is perfectly balanced and profoundly peaceful. The rhythmic venting of the Earth continues constantly. It is the slow heartbeat of our planet. As you lie in the quiet of night, imagine the gentle sway of the deep currents. Picture the warm glow of a research submersible. The deep sea remains calm, dark, and undisturbed. It is a place of eternal, quiet rest. Let your mind drift into these peaceful depths. Release the tensions of your waking daily life. Allow the mysteries of the ocean to soothe. Thank you for joining this deep sea exploration. The